Galactic Archaeology is a method to piece together the formation and evolutionary timeline of galaxies like our home, the Milky Way. There are many steps that go into building a galaxy, and many different processes create the environments and building blocks for the way the universe looks today. It's a growing field, incorporating chemistry, cosmology, nuclear physics, stellar physics, dynamics, and much more. One of the main ways to see how galaxies evolve is by looking at their constituent chemicals. To understand that, we'll have to go back to the Big Bang. After a messy first few seconds, the universe consisted mainly of hydrogen and helium, and negligible amounts of heavier elements. With this as our starting point, we conclude that the rest of the periodic table was forged inside stars going through nuclear fusion and supernova processes. It's all stardust. The interplay between galaxies causes massive streams of material to fling across intergalactic space, and gravitational forces push and pull material around, sometimes causing a dust cloud to collapse in on itself and ignite. Tracking where these elements came from can tell us about the history of the galaxies and the stars that lived and died within. One of the foundational papers in the field, Epochs of Early Type Galaxy Formation as a Function of Environment, from 2005, sets out some techniques involving spectroscopy and metallicity observations. Spectroscopy uses the interactions between atoms and light to tell what chemicals are in your sample, and each element has its own barcode. Using this information, ratios between different elements can be made, and ages of stars can be inferred. Stars formed earlier in the universe's history will have fewer contaminants, and each subsequent generation will be formed with a higher fraction of heavy metals. The ratio of these elements tells galactic archaeologists about the different nucleosynthetic processes that must have happened to produce the observations. More recent studies build on the same ideas. The Galar survey is an Australian-based project using the Hermes spectrographic instrument at the Australian Astronomical Observatory in New South Wales. The survey has spent a decade capturing high-resolution spectra from 1 million stars and have produced accurate measurements of the star's chemical makeup. And just look at their cute little web icon. By using this data in conjunction with astrometric data from the Gaia survey, the results can be refined further. Spectroscopy must account for star motion causing Doppler shifts after all. Chemical tagging of different galactic regions is now so precise that scientists can even identify stars who were born in the same stellar nursery dust cloud, even after they have grown up and gone their separate ways. With a plethora of new data from Galar, the 4th data release just coming out, and efforts using the James Webb Telescope, there is plenty more to glean about the processes that form the galaxy, stars, and the elements that make up the world around us. For more information, check out the ANU webpage, Galar's website, and the papers listed here. Thanks very much!